Welcome to Data Skeptic, a podcast exploring the methods, use cases, and consequences of recommender systems. Welcome to another installment of Data Skeptic Recommender Systems. Today we're focused on one of my favorite topics, music, or more specifically, music recommendations in the form of playlist generation. Our guest today, Rebecca, has an excellent background. We start out the discussion talking mostly about fairness because I got curious when I learned about her work in this area, but eventually we're getting around to talking about LARP, as well as MusicSim. That's a novel framework and an outstanding research data set available for work in this area. We cover a lot of ground, so I'm going to cut the intro short and jump right into our discussion.
My name's Rebecca Salganik, and I'm affiliated with the University of Rochester, where I'm co-supervised by Jian King and Anson Kong. So I'm in the second year of my PhD, and I work on fairness in general, and then I apply it often to graphs, recommender systems, and more recently, dynamic systems and computational social choice.
So I know you've done a lot of applications in music. How did you get started applying your craft and recommenders to music specifically?
So actually, I started with an interest in music. So a lot of the work that I do is applied to music because it's both an industry and academic kind of like open research question. How do we define similarity in music? How do we apply recommender systems to music? So I had a background in music. I went to conservatory. I did a classical degree in voice and composition. And while I was there, I started taking computer science classes. I was working as a songwriter, and one of the things that I was interested in is, okay, there's all these recommender systems, and they are essentially becoming the gatekeepers for how music is created, consumed, and commodified. How can I learn about these systems to help my music get discovered? And that kind of transitioned into research in recommender systems, which then also kind of transitioned into research on fairness, because I started to see a lot of the problems that I had been facing were actually byproducts of certain aspects of recommender system design. And so fairness is a tool for addressing this misalignment between what we want recommender systems to do, which is kind of help people discover new things, and what they currently do, which is often perpetuate mainstream patterns in people's consumption habits, right? So fairness is in the real world. Fairness is an experience that someone has. It's very personalized, and so it's kind of nebulous. But if we want to apply it to machine learning, then what we want to do is basically be able to formalize it with respect to some sort of variables and mathematical functions so that we can assess the relationship between the different outputs of an algorithmic system. So there are generally three different branches of fairness, and they're basically defined based on what kind of information you're going to use when you're talking about fairness. So the most kind of canonical one is called group fairness, and that has a basis in kind of like our legal system. So it's the idea of like protected groups and sensitive attributes. We can talk about like race, gender, ethnicity, socioeconomic background. And so if you have the presence of these demographic information, then what you can do is you can look for equality. You can say when you have an algorithmic system that interacts with someone from a protected group and a non-protected group, what's the difference between the kinds of outcomes it produces? That's kind of the most canonical one. The one that I focus most on is called individual fairness. And the idea here is that an algorithmic system should treat similar individuals similarly. And we can dive into what that means, but I'm just going to kind of cover the third one, which is called counterfactual fairness. So what we know is that like sociodemographics, kind of our protected attributes, are not the only information that we need when we try to equalize for fairness, right? So there can be confounding factors that affect somebody. For example, if we're talking about ranking candidates for a job, that kind of barred them from being able to achieve the same kinds of qualifications that another person could. But that doesn't mean that they are less qualified. So what it tries to do is it tries to understand how different variables affect each other and try to kind of denoise the information that might be causing bias.
So fairness is, at least in my survey, a relatively new introduction when applied to recommenders. How did you first take an interest in this intersection?
So the reason that I personally find individual fairness the most compelling is because I think what I'm trying to do in my work is to understand like this experience of fairness, right? When we experience unfairness, we see a person who looks like us or is similar to us in some way get something that we want or achieve an algorithmic outcome that we would have desired that we ourselves are not able to achieve. And so the way that individual fairness works is given some information about individuals, we can define similarity between them. And then what we can do is we can say, okay, we have this information about which individuals are similar, and we also have information about their algorithmic outcomes. How different are those? And so sneak preview for recommender systems, where we do talk a lot about similarity, individual fairness ends up playing a really important role.
If I were going to come at this from a naive perspective, let's say I brought my knowledge of machine learning to the table, but I didn't know much about music, and for some reason I decided to take on music recommendations, a first step in any ML project is featureization. How do we take our raw data and make some features out of it that we can learn from and use? Maybe step one would be to get the key of the music or the tempo or things like that, but that's probably a little bit too low level for describing what people actually care about in the music. Ultimately, it's like the creativity of music that people prefer and are kind of after. What are your thoughts on how you approach capturing that in some mathematical way?
So I can give you my take, but there is no one true answer, right? So if we want to backtrack and say, what do we want recommender systems to do? The answer is that different people want recommender systems to do different things. So people have different objectives, and there are certainly many mainstream listeners who want to press play and have pop music come out of their system, right? But then there are also people who have more niche listening tastes. And that's actually the focus of my research, is being able to find recommender systems that can modulate between the two. Because I would say that from my understanding, we've currently done a really great job in the last 10 years of designing systems that can serve mainstream tastes. But people who have diverse and niche tastes are often less represented in algorithmic design. So if you're asking me, what should a recommender system be thinking about? So in general, in the recommendation space, we have two different kinds of information that we can give it. We have content, which is what you were suggesting, right, with the kind of theory of the music. The reason it's called content-based representation is because the only thing you care about is like the song itself, the content you have. And then we have context-based representation, which is often also called collaborative filtering, where you actually don't care what the song sounds like. What you really care about is what people think like songs are similar. So for example, user one listened to these three songs together in one playlist. That must mean that these songs are similar. So these are kind of the two perspectives. Right now, if we look at what's happening in the industry, most of them are hybrid, right? So they're kind of mixing between the two. But how to mix between the two, what information we should be giving is kind of like the core of recommendation research in the music domain.
Given your expertise in this area, could you overview what it would be for a recommender system to be unfair in some way?
So there's many different ways. I'm going to start with the one that I work on the most. So that's what we call like producer fairness. And so that's thinking about like exposure that you give to artists. So, I mean, societally, we understand that when people listen to music, artists get paid. If you do not listen to their music, they will not get paid. They will not make more music, right? So for independent artists, for niche artists who have less listeners, it is absolutely an economic question whether or not they will be able to make more music in the future. And the algorithm's decision of recommending their songs or not basically gatekeeps whether they stay musicians or not. So that's the kind of unfairness that I think about. Now, what we have are different biases that are built into the algorithm because of the training data that we give it. And popularity bias is the one that I focus on the most. And as you can intuit from the name, here what the algorithm does is that it is biased towards popular content. It is biased against unpopular content, which could be niche content, but it could also be new content. So a new artist that places their music on the platform. Another recent work that I've been really interested in is users. So, one of the things that a recommender system does when it tries to make a recommendation is it tries to unify its understanding of a user using what's called an embedding, right? So, this is just a representation of the user, how it understands your taste. But the thing is, when it does that, is it's only got one understanding. And if you have a very, very broad and diverse range of tastes versus another user whose tastes are kind of like simple to capture, so you have an equal amount of space that you can use to represent those two users. And so there are recent findings that show that users who have diverse consumption patterns are less well represented by algorithmic systems. So this is another form of bias. I guess it would be called multi-interest bias.
Well, a problem we see in every recommender system, playlist recommendation is no exception, is the cold start problem. For a new user, you don't know much about them yet, they haven't revealed any useful signals, yet you've got to do something for them to get it going. I guess we could design like a one-size-fits-all model that kind of works for most people and that it would get us somewhere, but I would think we could do better than that. How do you go about it?
One of the problems with popularity bias, as I was mentioning before, is that oftentimes an algorithmic system needs contextual information, right? So collaborative information in order to represent an item. So we need someone to have already listened to that song. We need that song to be placed in the playlist or interacted with to some degree before the algorithm can use content-based representation. But the problem is that when we have a new user or we have a new song or a new artist that is put onto the platform, you cannot use context-based representation because it doesn't have enough interactions for us to use that methodology. So we have to go back and we have to rely on content-based representation. So this is called the cold start problem. It happens not just in like music recommendation, it happens all over in other forms of recommendation, e-commerce, and whatnot. So one of the things that we have to do is we have to find a way to represent items, even though we don't have interaction patterns for them. And so that's what I worked on in LARP.
So LARP is a multi-stage framework. Could you walk us through each stage?
So in general, the way that LARP works is that in the past, content-based representation methods, as we mentioned in like the earlier part of our conversation, were really only using the music. So information about the acoustics was kind of what we were using to define similarity between songs. But what we tried to do in LARP is to make this what's called multimodal. So we want not just the audio, but also the text to be able to represent the song. And so in order to achieve this, what you need to do is called multimodal alignment. So let's say you have a machine learning model that reasons about text. You have a machine learning model that reasons about audio. How do you combine the two such that they're in the same representational space? This is an important question for being able to represent a song. And before I dive into more to that, let me give some precursor. The way in general that recommender systems work is they define a embedding space where they put all of the songs, like the entire song catalog, into this embedding space. So that when it's time, and this embedding space takes a long time to model and a long time to build. And when it's time to serve recommendations, like you're clicking next on a radio and it's like suggesting the next song, all of that has been pre-computed before. And what the recommender system is really doing is it's just going into that embedding space and it's looking for things that are close together in that embedding space. What we can say is we've defined a mathematical function of distance. So like we're close together, and that is a proxy for similarity in this space. But how you build this space, how you organize items in that space, that's the key question of multimodal learning. And that's the real question of recommendation systems, because once you've constructed this space, bringing stuff out of it, like making the recommendations themselves, is not the complicated part.
So there's lots you could embed. You have different forms of data about music. What do you actually use in your case?
We have this model that has a space that reasons about text. So you give it a song and it puts that song in the space. It represents it in that space. And you have the same thing for audio. But the problem is that these two spaces are different. What we need to do is kind of make sure that those spaces are aligned. So the way that our framework works is it's used something called contrastive learning. So what it tries to do is it tries to first teach the algorithm just to align on the basis of one song. So I give you the text of that song and I give you the audio of the song, and the algorithm needs to learn that this is the same song so that when it embeds it in the space, that's the correct place and all of the embedding is aligned. So the text and the audio are representative together. But then when we think about how people try to make judgments about similarity between songs, they're not just thinking about like the individual elements of that song, they're also thinking about that song in relation to another song. So what we do is we sample another track. Let's say we have 2 songs in a playlist. We will sample another song in the same playlist, and we will try to align on the basis of those. So now we'll talk about the text from one song and the audio from the other song, the text from the second song and the audio from the first song, and we try to reason about where in space they should be, right? Ideally, they should be close together. And on the last stage, what we want to now do is we want to zoom out and get more abstract. So in the playlist continuation space, right, where we're trying to help a user build out a playlist, what we need to do is we also need to make sure that all of the songs that are in a playlist are close together in this space. So again, when the recommender system is trying to help you build out your playlist, it can go into that space and find the other songs that are close together with the ones you've already suggested. And so what we do is now alignment on the basis of the songs and also the playlist.
In terms of the text you can use, is that lyrics or what sort of textual data do you have?
In our work, we just work with what's called the metadata. We don't work with the lyrics, although you could use our framework for that. The data sets that contain lyrics are often harder to get access to when you work in academia. So what we work with is just the description. So maybe the playlist name, the song name, the artist name, the genre that the artist participates in, and also the album, that kind of information.
So creating embeddings for your features is a pretty popular approach, and for good reason. But those embeddings are embedding something, some like kind of raw data, or perhaps raw features. Can you talk a little bit about your starting point and the inputs to the embedding? How do you represent my music taste as a vector?
Right. So just to be clear here, what we're trying to do is not necessarily embed your music preference, but what we're trying to do is embed a song in relation to other songs. So when we represent you, we might use a different methodology. But in this particular case, we've got new songs or new users. We don't know what your preferences are yet. So we're forced to work only with the information that is available to us from kind of the intake. So when you're asking, like, what is the input to the framework? Great question. So we have some songs and we have a text associated with each song. So for example, this song is Viva La Vida by Coldplay. It has the following genres associated with it, and it was in this following year, and it's part of the following album. And then we also have the audio, like the MP3 file, the waveform associated with Viva La Vida. And then we have the playlist that this particular song was in. So maybe songs by Coldplay. And we have all the other songs that were in that playlist. And so when we train the first stage, the input that we give to our algorithm is going to be just the text and the audio of the first song, Viva La Vida by Coldplay, and its audio. When we train the second stage, we have 2 songs, maybe Viva La Vida and then also Yellow, right? Because we're looking at songs by Coldplay and we have their textual annotation and we also have their audio. And then for the last one, we'll have the playlist. So what we'll do is we'll take the first 10 songs of that playlist, represent them as individual songs, right? We'll pass them through the network and we'll get like their text and their audio and their unified embedding. And then we'll average them together. And that's going to be the playlist representation. And we're going to pass that into the third stage of the algorithm.
So I probably should have asked this earlier, but all these multi-stages, they all make sense towards an end goal. But what is that actual end goal? What is your framework trying to achieve?
The setting that we're working with is called playlist continuation, where the idea is that a user is starting to build out a playlist, and we only know the information that they gave us about this playlist. So maybe they gave us what we call seed tracks. So maybe like 1 or 2 songs that they have put in this playlist. And now what we want to do is to make suggestions for what else belongs in that playlist. But again, because we don't necessarily have information about some of these songs or the user preferences, we can't just use normal collaborative filtering. So what we do is first we take our entire catalog of songs and we pass them through this. So we pre-trained this model, and now what it can do is it can embed songs. So for all of the songs in our catalog, we pass them through this pre-trained module, and we have these representations. And then we look at the seed tracks that the user has already given us, and we try to find the K nearest songs in the embedding space. So let's say we want to suggest 10, 5, 20, that's going to be K. That's our hyperparameter. And then what we want to do is we want to build a playlist for them, which has like a set of suggested tracks.
Right now, the headlines are chock full of data breaches and regulatory rollbacks, making us all vulnerable. But you can do something about it. Delete Me is here to make it easy, quick, and safe to remove your personal data online. Your data is a commodity. Anyone on the web can buy your private details. This can lead to identity theft, phishing attempts, or harassment. But now you can protect your privacy. That's why I've been using Delete Me. One of the best things about the service is when you first sign up, they give you the flexibility to start with just basic information. You choose what details you want them to protect. Some removals happen within 24 hours, while others might take a few weeks, but Delete Me manages it all. They keep you informed throughout the process, and their quarterly reports show you exactly what they're doing to protect your privacy. Take control of your data and keep your private life private by signing up for Delete Me. Now at a special discount for our listeners, get 20% off your Delete Me plan when you go to joindeleteme.com/data and use the promo code DATA at checkout. The only way you get the 20% off is to go to joindeleteme.com/data. Enter code DATA at checkout. That's joindeleteme.com/data, code DATA. Much like any research effort, you're going to need some data set to work on to build your system. But to the best of my knowledge, the majority of these, especially in music recommendation systems, they're developed in industry. That usually means they're proprietary, they're private. You may not have access to the thing you'd most like to have. What sorts of data sets are you able to get access to?
So when you work in academia in recommender systems, one of the challenges is getting data sets. And in music, this is even more challenging because of copyright issues. So what we do is we work with two different data sets that have been released publicly. So in this project, the data sets that we used are the Last.fm dataset and the Million Playlist dataset. Both of them come from proprietary companies that essentially released their data publicly for the academic community to use. So what we mostly focused on is the Million Playlist dataset, which was released in 2018 by Spotify. This dataset is basically structured around playlists made by users. And so the idea is that we want to perform what's called playlist continuation, which is like a really important task now in music recommendation in general, because people don't listen to albums anymore. They listen to playlists, which is basically like them creating their own album around some theme. And so in this particular project, we were just using the metadata that is associated with a playlist when we were talking about the textual descriptions that go with the audio. But in the future world, we can see kind of the need for something more complex there. Right, so when we think about the ways in which people connect with music, they're often using what we call semantics. So like when professional musicians describe music, they often describe the music in terms of the valence or the tempo or the BPM or the modes or something about the instruments. And so when we were working in our experiments, we had access to Spotify's like audio characteristics, which talked about kind of the instrumentalness or the vocalness. But what we can find from like human-computer interaction studies is that when normal people talk about music, they often talk about the atmosphere that it's evoking. And that can be kind of like a semantic idea, right? For example, this song makes me feel like I'm drinking a pumpkin spice latte, or the context in which someone was listening to something. So at the moment, we have like very high-level granular contexts, right? So like sports or something like that. But we don't have like, I listened to the song when I quit my 9 to 5 corporate job, or I listened to the song when I broke up with my toxic ex-girlfriend. So these are the kind of like really granular semantic informations that people use to connect with music. And I think that the next frontier in music recommendation is being able to design algorithmic systems that are able to perform the kind of contrastive learning that I talked about in LARP, but on like more complex, like textual descriptions of the audio. So, one of the extensions to this project that we're working on right now is where do we get this semantic information? So, in a perfect world, I mean, if you were in an industry setting, you could have A B tests where you opened yourself up to this kind of explicit feedback from your listeners. So, listeners could like type in what they're looking for. For example, I'm looking for a song to pump me up to quit my horrible corporate 9 to 5, right? And then the algorithmic system would be able to kind of perform the kind of contrastive learning we were talking about based on this really explicit feedback. But since I'm not in the industry, I'm in academia, this doesn't exist. So one of the projects that I'm currently working on, and it's under revision, is designing a data set that has this kind of semantic information. So first, what I did is we went through all of the different kinds of ways in which people talk about music, and we presented a taxonomy of the different kinds of things that we want to see in future data sets. What kinds of ways do people talk about music? So there is obviously descriptive, which is when people describe the music, for example, the bass in the track or the BPM of the song. And then there are other semantic categories like atmospheric or contextual or situational. So for example, atmospheric would be like, this song feels like a warm hug, right? So it's kind of some adjectives that describe a feeling, a vibe, an aesthetic. Then there's also contextual. This song sounds like Dua Lipa mixed with Ariana Grande, mixed with Bruno Mars. Or you can have something like situational. For example, I listened to the song in the summer driving in the car with my windows down. And so once we have this taxonomy, what we do is we go on Reddit and we scrape Reddit, all of the music threads where people talk about music, and we try to find what song they were talking about and how they described it. And so what you can see is that there's like a whole huge amount of discourse, organic discourse that people are kind of contributing where they talk about the ways in which they connect with music, which is very different from the ways that like professional musicians would annotate a song. And so this data set is actually already available on Hugging Face. It's called MusicSem, Music Semantics. Hopefully the paper that describes it and all of the experiments we ran on it, I mean, that's under revision, but it will hopefully be out in the future. And the idea is that this kind of data set can facilitate lots of different kinds of tasks. Because, I mean, as I mentioned before, multimodal learning and contrastive learning between like text and audio is a really hot kind of direction for research in general. But one of the things that's been lacking is access to this like really granular, semantic, organic text annotations. And so let's say you wanted to use it for recommendation or other retrieval tasks. That's definitely something you can use. But also if you wanted to talk about like other frontiers, right? So there are lots of people who are saying that the future is like generative art, that there's going to be a lot of like music generation. And already there are many, many models where you input text and it generates you audio based on that text. So when you talk about how you want that text to sound, you also need a model that is like aware of these kinds of semantics. And often underlying the generation process, there is also this like contrastive learning where you're training the model to associate like some textual descriptions with some audio. And so this data set is also really compatible with that. And then thinking even further down the line of like music videos or adding a third modality, because the data set is compatible with like the unique identifiers that are used both on Spotify and in YouTube, what you can do is you can find like the music videos that are associated with a song and try to train a model for that. So I think that is kind of the research direction that I'm hoping to work on. And the way that that ties into discovery is that in order to be able to facilitate discovery, as I mentioned earlier, like you need to be able to interact with the user and say, what about this song did you like? But when they give you the answer, you have to have a model that understands that, right? So if somebody said, I like this song because it made me feel something, right? For example, one of the entries in the data set that like really touched me was we listened to this song while my girlfriend had chemo. So why do you like this song? I like this song because it made me feel supported or close to her or happy or hopeful. That is not an audio description, right? That's not like because the BPM is 120. It's much more complex than that. And so we need this kind of data in order to facilitate this kinds of interactions between users and algorithmic systems. And hopefully, if you can explain yourself better, then the model can understand you better. And then you can discover more music that has more, I guess, the kinds of recommendations it'll make will be more complex.
Yeah, it makes perfect sense that you want a lot more semantic data, just knowing like the key the music is. I don't think anyone's partial to F sharp major or something like that. These easy signal processing features don't really tell the full story. Going out to Reddit is a pretty clever idea, but it also gets you into sort of an unstructured data problem. What do you do with the crawl you've done?
Yeah, so that was basically one of the major challenges that we had to overcome, right? So how do we define these semantic categories and then how do we like meaningfully extract them? So what we did is we did a bunch of ablation studies with lots of different LLMs, and we made our own synthetic data set, and we looked to see which ones were able to extract the information we wanted. So we tried to refine the prompts that we were giving them. So first we had to define the taxonomy, right? So semantic, situational, atmospheric, contextual, descriptive, what we mean by that. And then we looked to see how well these models were able to extract that information from our synthetic data. And so from that, we chose the GPT-4o model. We tried some reasoning models, we tried Claude, we tried some open source models, and in the end, we decided to go with GPT. And so we had GPT extract portions of the text. So it's not rephrasing them, it's given instructions to just explicitly take the portions of the text that are associated with some semantic tag. So the same block of text can have many kinds of semantic information. For example, this song makes me feel like a warm hug because I listened to it while my girlfriend was going through chemo. So that would be something like situational because it's a situation in which you listen to it, but it would also be the atmosphere because that's how it made the person feel. And it would extract those portions. And then what we would do is we would also extract all of the songs that were mentioned in the post. So maybe someone would say, these 4 songs, they would list like title artist, title artist, title artist, make me feel blah, blah, blah. And so we would extract all of those pairs and then we would look for them on the Spotify platform. So if you can't find a song, that's a good indicator that your LLM has hallucinated. So we would throw those out. But if it can find the song on Spotify, then you can get the unique Spotify identifier. And then there is a database where you can map that to YouTube. So if it exists both on Spotify and on YouTube, then you've kind of got a pretty good proxy for like, this is valid, it exists. And then we would scrape the audio. And then that's kind of the entry in a data set. So all of these semantic tags. And then also if you want to like maybe reformulate these semantic tags that we've extracted into like one long sentence, we would have another LLM that would do that. And then we would use the other LLM to check the extraction to make sure that the extraction was valid to some extent. So of course, whenever you're using LLMs to do any form of like large scale extraction, you have no guarantees that your data set has no hallucinations. But we did our best. And in the end, the data set is about 35,000 entries. And then we manually read over those entries because, of course, like publishing Reddit data can be sensitive. And this is something that we were really careful with. So we wanted to make sure that there were no, for example, PII, like identifying information that someone might have. I mean, music is not the most sensitive topic, but it can get personal. And so obviously Reddit is anonymized, which is why we chose Reddit in particular to like have as much anonymity to these people as possible. We also cut off all of our scrapes from like anything after 2022 is not in our data set because Maybe that's too close to home. Maybe it's too personal. And then, yeah, we just tried to make sure no one's name is anywhere, no one's user ID, and just to read over the entries to look for any form of hallucinations. That was our scraping protocol.
So it seems like MusicSem offers a pretty rich data set then. Do you have a vision for maybe how other researchers might extend and build upon your work?
Yeah, so we published already the code for the pipeline for how we designed MusicSem, and we didn't scrape like exhaustively all the threads in music on Reddit in the world, right? We only actually took like 7 or 8 threads because, of course, we have limitations in terms of our computational resources, and there's a time horizon where we wanted to finish. But because we released this pipeline and all of the reproducibility information, hopefully people can continue to expand it. Also, what I think is, I guess, what I feel most proud of is this taxonomy of the semantics, right? This understanding that just having descriptions is not enough, that we need to be able to simulate like organic human discourse, I think is really important, particularly in the generative space where many of the current data sets that are available are very small in scale and also focus almost exclusively on descriptive information, which is because they're annotated by professional annotators, mostly musicians. And the language between the way that musicians talk and the way that normal people talk forms this kind of interpretation gap. Like the model just like won't understand the way normal people talk. For example, if somebody says, I want a boopy bass, like what does that mean, right? Like you and we can picture what that means, but the model probably won't be able to if it hasn't been exposed to that kind of adjective.
If you had no constraints or infinite resources here, where would you like to take it? There's 35,000 entries. One dimension be add more entries or expand the taxonomy or who knows what. Where would you take it next if you had more resources?
So there's a recent paper that was published which has conversational multi-turn dialogues between a person and a system. So the person says, this is what I want. And the system says, is this what you mean? But that is a very small data set and it's very, I guess, limited in its semantic information. So if you look at kind of the kind of information, again, that people are using there, because the people were prompted to describe the music they're interested in using a specific template, they mostly talk about like genres and artists. I would really love to be able to get or maybe simulate from MusicSem a set of conversations between a person and an LLM, where the LLM starts asking what I would consider to be insightful questions that are not just like metadata based, right? Like, what genres do you like, but more like, what are you feeling today? I think if you look at what Spotify, Deezer, and Apple are doing right now, and also Pandora, I think that there is a thrust to try and describe people's tastes using more complex adjectives rather than just genres. And that's what I would really like to do with MusicSem. So to design conversational models that are able to explicitly query the semantic associations they're making with the music they're listening to.
And do you find that there is, I guess I'm thinking about my own experience with music and maybe the experience of others. I have a guitar player friend who loves Zappa, and I think he likes songs that are novel from a musicology point of view, is sort of one way to put it. Whereas maybe it's more common people just want an emotion or something to be evocative. It's very personal experience overall. How do you develop a good set of features that can apply to as broad of a group of people as possible?
Yeah, so that's a great question, right? How do we suit different levels of expertise in music is also a really important research question. But how do you even assess a person's level of expertise if you cannot ask them about it? There's like another really interesting extension to MusicSem is maybe we can't have we don't know who these users are. So we don't know their level of expertise. But there are specific threads that are geared towards amateurs and geared towards professional musicians, right? So, for example, threads where producers give each other feedback, that language is much more technical. So, teaching models as well to understand a person's level of expertise will be a great indicator for how to serve their listening tastes. Because something that you'll find is like there's a really big difference between an expert, perhaps your guitar friend who says, I like rock music, and some random person on the street who likes rock music. what they mean can also be really different. Like the idea between like generalists and specialists is also something I would really like to address in the future.
Ideally, maybe you could launch your approach on one of the existing platforms. And I hope maybe one of them would choose to adopt your work in some way, and then you could get some learnings there. In lieu of that, how do you evaluate the degree to which your framework is working?
So we have a training set and we have a test set. So what we're trying to do is, so the way that that works is we have a set of interactions, maybe playlists and all of the songs that were in them, or users and the songs that they were listening to when we started recommending, right? And so what we can do is we can mask out maybe the last 10 songs of a playlist or the last 20 songs of a playlist, right? Here we use our K parameter, the threshold, how many songs we want to recommend, basically. And so what we do is we mask them out and then we recommend the songs that we think should go in those places. And then we look at the overlap between the songs that we recommended and the songs that like were in our test set.
Well, let's say you were hired by one of those companies and they wanted to put your ideas to work. What sorts of evaluations could you do in that scenario?
Also a great question. So yes, in the industry, what often happens when you want to evaluate whether or not an algorithm is doing well is you define some sort of proxy for user satisfaction based on your playlist. And then when you make your recommendation, what you can gather is like real user feedback as to whether or not they interacted with your recommendations. Every company will have its own standards and it will depend very much on the experiments that they want to run. But we can think about something like, we recommended you a song. Did you add it to the playlist, right? Or we recommended you a song. Did you listen to more than 30 seconds of it? For sure, if you listened to 15 seconds of it and went, no thanks, then that's definitely not the right answer, right? But what I think you're pointing out here is that there is certainly a gap between offline experiments, which is kind of like what we performed here, right? Without any real user feedback, and online experiments where you're actually like making recommendations and getting information back from a user.
I know you may not know exactly what industry is doing, but do you have a sense where you can compare your work to traditional approaches?
So in our particular work, one of the questions we were asking is multimodal representation even useful? Because some of the streaming platforms don't necessarily use it. Or at the time when we were publishing this paper, it wasn't necessarily like obvious that it would be useful. So what we did is we compared with some of the state-of-the-art models that were trained on huge amounts of proprietary data to just learn information based off of the audio. Not audio and text, but just audio. This is part of a like larger research direction that I'm particularly interested in, which is the idea of like, harnessing textual input from users to be able to really interpret what about the audio they're interested in. So what our paper showed is that yes, indeed, like text is very, like combining text and audio is very meaningful. And what we're hoping to work on this year, essentially, is to expand like how that like the depth of that textual information. So at the moment, what we're working with is just metadata-based textual information, as you rightly pointed out, right? Like just like the song Viva La Vida by Coldplay. But you can also think about a future world where a user actually describes the song in their own language. And you use that and you align it with audio in order to be able to better understand their understanding of the audio. Like, what about the audio did they even like?
Do you have any thoughts on the direction in general research is going and maybe how work like yours can push recommender systems forward?
I think I touched on this a little bit when we were talking about what do I wish I could see in like recommenders in the future. So one of the major focus of my research, kind of the overarching umbrella term that I focus on, is this idea of discovery. So as our consumption patterns have moved towards platforms, this is kind of called like platformization, right? We no longer discover music by going to a radio store and finding an album and just kind of trying it. What we do is we go on a streaming platform where the algorithm is basically supposed to play the role of our friend that is supposed to like find us songs that are really cool. But the issue with that is that a lot of people feel very frustrated by this ceiling that they hit with recommender systems, where they feel like it's gotten to a place where it's just recommending the same thing to them over and over again, or it's just zeroing in on one of their tastes and not their more niche tastes, and it's not exposing them to new things, right? So lots and lots of users are looking to discover, and our algorithmic systems are not geared towards discovery. When we were talking about the metrics that you normally use to evaluate recommender systems, what we're talking about here is accuracy. We're looking at like what you liked in the past, how well can we predict that? But if you think about it intuitively, the point of discovery is not to recommend something that someone already liked. It's to find something new. In order to be able to do that, we have to move recommender systems away from implicit feedback and to prioritize things like popularity bias, diversity, facilitating niche tastes. Because without that, we are starting to see people who are leaving platforms, people who are frustrated with the quality of these algorithms, because the algorithms are geared towards serving mainstream users. I think initially when we started talking about my work, we framed it as a fairness question. And indeed, fairness is a tool through which we can fix this problem. But the like overarching question I try to focus on and answer in many different ways is what can we do to start facilitating better discovery for users?
I once saw a talk from an Amazon engineer who said, I presume jokingly, that his goal was that eventually you'd go to the Amazon homepage, it would display a single product, and you would immediately buy the product. And I guess the analogy in music would be every song you introduce to me is my next newest favorite song, and they keep supplanting the previous favorite song. But that obviously seems sort of ridiculous when put that way. What's the ultimate goal for music recommender systems? What does success look like?
Before I answer that, I just want to say I want to push back a little bit on like what we should be expecting from a recommender system in music. So it's funny that you draw this connection between e-commerce and like the recommendation of creative content because to me these objectives are fundamentally different. People in music are actually looking for diversity. If every single song was the most amazing song, I just don't think that's even humanly possible. The point is that when your friend recommends you stuff, actually what happens often is that your music taste stretches to accommodate that. Sometimes it takes 4, 5 listens to really get a song, right? So the idea of diversity is part of the enjoyment of a song. And the idea of being recommended something that you don't initially like is also part of that journey with creative content. Meanwhile, if I'm shopping on Amazon and I'm looking for toilet paper, I do not want the algorithmic system to say, hey, have you thought about plungers? Because I know that I want toilet paper, right? And also, if we think about the effort that a user has to put in order to engage with a product on Amazon, like they have to buy it. But in music, like all you have to do is listen to 30 seconds of it. So I think that the fact that e-commerce shapes so much of what recommender system literature kind of identifies as like gold standard is really hurting the recommendation community that's working on creative content because it's really, really different.
Well, the success of any recommender system is going to be at least somewhat dependent upon input from the users, whether it's implicit or explicit, thumbs up, thumbs down kind of stuff, or maybe listen time. What sorts of signals do you think would be most valuable?
Yeah, so you asked a question. I went on a monologue and didn't answer the previous one where you're like, how far away are we from an algorithmic system that's really able to like write like gold standard, help us discover awesome music? So I do think that we can achieve that. And I do think that there is a model that is able to do that. But that model needs to be able to interact with us because it needs to be able to get that kind of feedback that you're talking about, right? Like, this is what I want. today this is what I'm looking for. Even the idea that the same person can want different things in different genres. Like maybe like in pop, I'm like, yeah, show me whatever. But like for example in jazz, I'm super knowledgeable about jazz and I know what I like and I'm going to tell it to you. So that's why we started with LARP. So LARP was the first step in this kind of like multimodal alignment for retrieval. The next step is to have a model that can you say like, I like the bass in this song. It can understand like as the sentiment, bass as the like identifier for the acoustics. It can then go into the audio for the song, extract the bass, find other songs that are similar to that bass, serve it back to you, and then be like, okay, did I get that right? And have you say, no, I want the bass to be more boopy, and then to have it start all over again. So yeah, I think we can have a model, an underlying model that serves all of these needs, right? How we learn these embeddings doesn't necessarily need to drastically change, but how we understand what someone is looking for, there's a lot of room for improvement in that, I think.
Do you have a vision for how we bring that to the consumer?
Yes, absolutely. I would like to build a user interface where users describe what they like about a song and then interact with the model and then tell you whether the model did it right or not. In 2025, we just got like one small data set that looks like that. I think it's called the CPDC. It's the Conversational Collection of Playlist Continuation, conversational dialogues about playlist continuations, but it's very small. And when you train a machine learning model, you need bigger ones. So that's what I'm hoping for in the future. But I think we're not there yet because as far as I understand, Spotify, Deezer, Pandora, this is like happening right now. These are the beta tests that I think are happening right now.
Is there anywhere listeners can follow you and your work online?
I have a website, which is my full name, RebeccaSalganik.com, where I post my papers and sometimes my thoughts. And then also I run a reading group on fairness and information retrieval is kind of the topic that is started initially. And now it's kind of just like fairness and multimodal representational methods. And we have a page, it's called DEFIRST, DEFIRST. And we have a YouTube where we have like speakers come in, and I think that's where you can find me.
Rebecca, thank you so much for taking the time to come on and share your work.
Thank you so much. It was lovely to be here.